Hi, everyone. My name is Aaron Edell. I have been working in media and entertainment technology since about 2007, 2008. I started in archiving video cassette tapes, actually. We used to build robots that would take a tape, put it in a deck, play it, digitize it, clean it, create files. Metadata became a really big problem very quickly, especially when you're dealing with millions and millions of hours of assets. I spent a lot of time working on that, went through several acquisitions, and then machine learning around 2015 kind of came onto the scene, seemingly out of nowhere. I didn't know anything about it, but I saw that there was a lot of interesting applications for search. I still think media and entertainment has a really big problem with search and with archives and with managing assets and with managing metadata. And as Guillaume mentioned, sometimes the industry lags a little bit in the adoption of technology. So bottom line is I spent since 2015 until today thinking about implementing and trying to apply machine learning to this problem. Interestingly enough, and I've been through about 3 different companies now doing this, I have kind of culminated into where I think we are today. And I tried to center my presentation around that a little bit, mostly about talking about where I've seen it work. And I still think that M&E is one of the more challenging aspects of this. So if you'll notice a theme to where we have successfully applied machine learning, and to companies and enterprises that are making money or saving money doing it, which is essentially the goal here. I think apply to how we can apply it to M&E effectively going forward. And it really has to do with the way you think about it. So I started a startup in 2018, very early, called MachineBox, and we made machine learning technology for companies to integrate. They were developer-focused tools. Veritone acquired us a little bit less than a year ago. So I am now working there to try and bring that technology into their grander AI platform and help customers solve problems. So why am I up here? It's a good question. I want to talk about the challenges. So, it's really fun to come up here and tell you about all the great things AI can do and machine learning can do and how wonderful it is. But I think it's probably more useful for me to tell you where the challenges remain. A good business case is number one, the challenge. I cannot tell you how many meetings I've sat in where the customer or whomever just thinks that machine learning will solve all their problems. It's a kitchen sink approach. Oh, we've got this problem. Let's use machine learning. How? I don't know. Machine learning. Just go. That's not going to work. Machine learning is not a deterministic system. Okay? So what does that mean? That means if I ask it a question, it might give me the correct answer or it might not. I mean, that's a little weird, right? We have to think about machine learning as a system that gives us back probabilities. As an aggregate, as a whole, that can be very valuable to us and very useful to us, as anybody who implements data science or statistics knows. Machine learning is no different. So the other challenge is people who know that, people who are skilled enough to implement that, who can understand how that works in a business case, but also how the technology works and how it can be implemented. Having enough good data, still a very large problem. Even as recently as a few months ago, I got asked about a use case where, can we have a drone sort of fly around some infrastructure and detect if there's issues using a camera, right? And I think, okay, maybe, right? That sounds hard. First and foremost, that's not an easy problem to solve, right? And of course, they always think it is. And the second question I always ask is, we need to train it. Where's your training data? Can you find some? No. I mean, we can't just go out and invent training data, right? We can. It's called synthetic training data, but we find that it just doesn't work as well as real training data. The problem, of course, is that they don't have anomalies in their infrastructure very often. So there just aren't enough examples of when it goes wrong to train it in the first place. Building production code around a system that's not deterministic and a system that requires a lot of infrastructure is still very challenging. And the people who understand how to deploy that production code and how to build software are not the same people who understand statistics and data science and machine learning. They're merging. part of what I did with my startup and continue to do today is to try and push them together, or give the developers, the people who do know how to deploy code and write software, the tools to do the machine learning part. But these still remain some challenges. So breaking down into these a little bit more, 37% of managers don't understand cognitive technologies or how they work. All right, so this is kind of what I was just talking about. AI gets oversold. It just does. And I think that people focus a lot on the technology and not on the problem. It reminds me of the internet. If I came up here and said, I've got a company, we've got internet. We're bringing internet to you. That's how we're solving your problem. I'm focusing on the technology. That seems silly now. The internet is a utility. Electricity is a utility. Machine learning is a technology. It's a utility, okay? It's not a technology that we can just sell. You have to think about the problem. What am I trying to solve? Why am I trying to solve it? I want this drone to fly around my infrastructure and detect anomalies. Why? Why are you doing that? Why do you need machine learning to do that? If you can answer these questions, then you can start solving the business case challenge. There's no, I think, doubt in anybody's mind here about the talent issue as it relates to data science and machine learning. We are getting to a place, I worked hard for this, where most people can implement machine learning without needing to be a PhD in data science, but some of the more challenging and more interesting aspects are going to require this knowledge. There just aren't that many people out there right now. It's growing, there's no doubt, but I think we can all agree there is somewhat of a talent issue. I wrote a blog post where the title was something like 80% of all data science engineers work at Google. And it was one of the most successful blog posts I've written. And I think this is an issue that really speaks to a lot of us as we're trying to run businesses. And I did go to a presentation or a conference a couple months ago where I saw a very interesting idea that some companies are trying, where they embed data scientists into every aspect of their organization. Instead of putting them together into a single department, they spread them out and they get them to think about the problems. And that's where you're going to see success. I talked about the good training data already. Training data should be real data. If you can tell the difference, if you're looking at something and you can tell the difference between it being real data and training data, then you have a problem. You shouldn't be able to tell the difference. You should be training it on your data. And as this relates to media and entertainment, if I'm trying to detect Jennifer Aniston in, let's say I'm NBC and I'm managing all the Friends content in my, content management system, and I want to detect where she appears and for how long and all that content. If I train it on a red carpet photo of her from, today, or, where she just looks different and the context is different, I am not going to see the same success as if I actually just grab a screenshot, draw a little box around her head, and train it with the face of her in the Friends episode. I'm going to see much better success, okay? That's sort of a microcosm of what I'm talking about. I have also seen a lot of instances where just the data is not clean. It was originally created by humans. I'll talk about this in one of my examples, and it wasn't clean, and it has to be clean. Building production code, data scientists are not developers. Developers are not data scientists. The other thing that I didn't mention before is that the user experience is everything. What happens when this is wrong? We don't even think about that, right? I run into meetings all the time where, oh, well, it returned the wrong logo or it returned the wrong face, so this must not be very good. That is the problem, right? This is where the expectation doesn't meet the reality. You have to have a user experience that understands that this system is not deterministic. So my favorite example of this is Apple Photos. Everybody here know Apple Photos? Yeah, okay, sorry, Google. Hope they're not listening. Google Photos does this too, it's the same thing. It will scan all your photos, it will detect all the faces, and then it'll say, who is this? Oh, this is Aaron. Okay, and it trains a machine learning model. Who is this? Oh, this is Eric, right? It's grouped all the photos of Eric, and then it trains a model. So then I come back to it, and it will periodically show me some examples. Who is this? And it will say, it's Eric, but it's not Eric. So it just says, is this Eric? No. Moving on. Is this Eric? Yes. Moving on. That is a wonderful user experience. We're training a machine learning model. It's implemented, and it's functioning for us. That's what I mean by user experience. It needs to be something that incorporates it being wrong sometimes with training it more and having that learning go into the feedback loop and creating this cycle, right, where We are training the models, and the models are giving us data and results, and we then say yes or no. Deploying production code, DevOps is not ops, is not dev, it's DevOps. What that really means is, how do I scale machine learning models, even just down to the tactics of it? I've got these, these Docker containers that require CPU and need to have post requests received from different places at different times and peak times and lots of data going through and blah blah blah. How do I scale that, right? This is a pretty typical problem, except for, once again, we are talking about a system that's not deterministic. So it needs to be in sync with the developers and the user experience and the business case. Okay, so these are 3 customers that when I was doing machine learning, when I was doing Machinebox, came to us and presented their business cases, and we were able to solve it with our tools. They went into production, and they're either making money or saving money. So these are some of my favorite successful implementations. And then I'll talk a little bit about how Veritone has done this too with M&E, because we did struggle with M&E when we were Machinebox, and Veritone kind of has the way to get around that, and I'll talk about that because it relates to these. So, and a big enterprise retail customer. You all know who they are. I'm just not allowed to tell you who they are, but you know who they are. They have a massive database of clothes. Every piece of clothing, article of clothing that they have has attributes. So this is a collared shirt. This is button down. It's blue. It's this. It's that. They when these articles of clothing get added to the database, they had a team of humans sitting there tagging them manually. They were filled with errors, right? Humans were making errors, but not to mention they were humans, and they were taking time and they were taking money, and this particular company wanted to see if they could save money by not using humans there. So they used one of our tools called Classification Box, which essentially they could take all their past data of human entered data with the product attributes, train it, and then deploy the model. And there were some challenges with the deployment aspect of it, because they needed to scale in something called Kubernetes, which is a very complicated piece of technology that requires some expertise. But the other problem that they ran into was that the data was really dirty, because that was the problem in the first place. The humans were making mistakes. So when he first ran this, they were getting an accuracy of about 80%. And that just wasn't quite good enough for their use case. So we sat there and thought, oh man, our tools are not good enough. We're not doing a good job. But then we thought, well, how's your data? Why don't you manually just look at your data? And he said, you're right, it's totally dirty, meaning there's lots of errors in there. Even a little bit of errored data can really throw a model off. So he cleaned it up, and the accuracy went up to 98%. So that's how important good training data really is. And a lot of people think that sometimes the machine learning will just magically figure stuff out, even if there's error in the training data. No. Okay, customer number 2. I pressed back. Customer number 2. So this was really interesting. Apparently, I don't know, I haven't done this. People hire other people to take tests for them. So this is a problem, right? You have standardized testing facilities. Somebody comes in, they really have no way to know that's you. Yes, you have an ID, but it's a scale problem. So these testing centers were running into errors, running into problems with scale. And these errors and these issues were compounding upon each other. So the solution turned out, and this was a customer came to us with this using our FaceBox technology, which is a face recognition model. They built this into their experience, which you can sort of see here. It's called Learner Verified, where the user comes with their driver's license. It trains on the image on your driver's license, because it only needs one image to learn your face. And then the webcam in the testing computer periodically just checks to make sure it's you. Simple, elegant. They offer it as a solution to their customers. They're making money. They didn't really have too many challenges, other than they just needed to solve, okay, where do I host this? Probably in some cloud servers. Sorry, Google. I didn't know this was going to be a Google facility. How to manage the training itself. So they needed to orchestrate, well, if you train on your face locally on that machine, what happens to that after you leave? So these are good challenges to solve. These are good implementations of machine learning. The third one was a legal software company that had clients that were law firms and or government agencies. And this was a kind of a loosey-goosey use case, and I struggled a little bit to understand it until they gave me a demo, which unfortunately I can't show you. But the basis is that there's just they have millions and millions of documents about all sorts of things, legal cases, problems with a chemical that's a known nerve agent or something to that effect, and you can't do a Google search, right, on this kind of data, because if you search for the word adverse effect or audit or compliance, everything with that word comes back. So there's no context. So we had a piece of technology that we implemented called text box, which is similar to the others, that just you throw your text at it, and what it does is it pulls out context around your words. So every time the word every time the word USDA was shown up, it would say this is an organization. Every time a person was mentioned, it would say this is a person. But it also would create these keywords, these searchable keywords that had context. So if I was searching for compliance, I could type that in, but then the results I would see would be compliance officer, compliance assets, compliance rule, compliance code, right? There would be this automatically generated context which let me browse. So there's a difference between search and browse. And browse solves the problem that you have when you don't know what you're searching for. You kind of know. I run into this problem with my email all the time. I know somebody sent me something and said a thing. Even though I'm searching for it, I can't find it. I need to browse. So as this kind of relates to the rest of media and entertainment, we kind of talked about face recognition. We talked about content classification. We talked about natural language processing. These tools, Veritone has used to a really good effect, and quite frankly, I'm quite pleased with. So speech to text is a big one. So we have a lot of media content, and there's a lot of audio content. If we can turn that speech into text, it becomes searchable. But we can do more. We can run natural language processing on that text and understand intent. We can understand, well, what is this? Is this an interview? Is this a sports game? Is this a movie? We can automatically classify that using these tools, right? This is what we're doing today. We can help, when we're broadcasting, we can help our ad buyers know that when they paid for a spot, we actually, in fact, did that native ad integration, right? This works in radio a lot of the times. And we can scan endless amounts. This is about solving the scale problem. We can scan endless amounts of radio content and look for the word Geico using speech to text and simple search tools, right? This isn't super rocket science. The challenge of it is the scale and the implementation and what happens when it's wrong and the user experience. And this is why, Veritone is really working hard to solve this problem, because it's not so much about the technology anymore, the implementation of the technology. It's about how you think about it. The good business case, having the skilled humans who understand the good business case and how it relates to the technology, having enough good data, right, training it on Jennifer Aniston, building the production code, the user experience, how that's managed when it's wrong, and then deploying it at scale. Orchestrate your training data. That's going to be a challenge that we all, once we get to this point. So when I train something, what happens to it? How do I segment it? Clean your data set. Make sure there's no errors in it if you are, in fact, training a model. Give developers tools that are easy for them to use, okay? Developers are like the rest of us. They're lazy. They don't want to go reinvent the wheel. They don't want to go back and get a PhD in data science, and then simplify the problem. So I could go on and on and on about this, as I've had before, but I want to open it up for questions and then, obviously talk more about it afterwards.